Hey folks, how's it going? This is Rob coming to you with a homework quiz video for homework quiz number 8 for Math 134 Spring 2020. This homework quiz covered, sections 12.1 through 12.2. 12.1 was concerning multivariable functions, and 12.2 was concerning partial derivatives. Okay, so in this one thing about directions, for 1 and 2, you had to choose one of the problems, and for 3 and 4, you had to choose one of the problems. So just make sure you're aware of that, because that kind of stuff, I do that to kind of give you more choice, but sometimes if you don't if you kind of skim over this direction, then you end up doing two problems when you could focus more on one problem, if that makes sense. All right, so if you chose one, most people did choose one, and you did correctly see that the idea is you're going to plug in the first number will be x and the second number will be y. The order matters. So you have 1 squared plus 2 times 1 times 2 minus 1 plus 3. That's 1 minus 4. Right? Let's just do this out. 1 plus 4 minus 1 plus 3. 5, 4, 7. Two, 1. So x is 2. So 2 squared, 2, 2, 1, 2, 3. Right? You're just plugging in. 4, 4, 2, 3. So 8, 6, 9. So you can see the order does really matter. You actually get two different outputs if you flip the numbers around. And that has to do with the fact that, yeah, you're doing different things with those numbers, right? Sometimes they'll end up being the same, but that's usually, or rather almost always, if not always, a coincidence. Okay, so now I'll do -1. So the trick here was when you minus the -1. That might have thrown some people off. So -1 squared, 1. 2 times 2 times. Now you want to subtract 4 because that 1 is negative. Okay, minusing -1, that's adding 1. So 1 minus 4 is -3, -2, 1, 0, 1. Okay, lastly, 2 -1, 2. So you're going to get 4. This will be -4 minus 2 plus 3. And that will get you 1. So that's a coincidence that those happen to be the same if you flip them around. But that doesn't always happen. And you can't assume that that is true. That's just how this particular function happened to be defined. Okay? Partial derivatives. This was not a bad one, but there was a little bit of confusion, so it's worth talking about. So first, I'm going to do the partial of g with respect to s. In other words, g little s. So here, you pretend like s is the variable and t is treated as a constant. So if I look at this, that would give me 2s, because I'm differentiating the s squared, because it's with respect to s. And the t would have gotten like fact, so it would have been like this, t, and then you would have done g little s of what was remaining, right? Like you factor it out like it's a constant. So it's 2s, right, times t. You're just rearranging. Okay, here, the derivative of s with respect to itself is 1. And then the t cubed would have gotten similarly removed, so you get something like this. If you want to simplify it, you can. If you leave it like this, I'm not going to be very picky here. Okay, or you could alternately write it. So there's a couple ways. You could alternately write it as 2st plus 1 over t cubed. Yeah, you could factor out an s, or factor out a t rather, and do 2s plus 1 over, it has to be t to the fourth. And think about if you distribute that in, you'd get t over t to the fourth would be t cubed. That, I guess, could be one way to do it. Not a lot of different ways to do it. I think any three of these would probably have been fine. Okay, how about now the derivative of g with respect to t? So that would be here s squared, because you look at t, the derivative of t with respect to t is 1. Okay, then you have minus, so you have to bring down the 3. So you're essentially bringing down the 3. So it becomes, from a plus, it becomes a minus. Then I put in the s. I just, if you do it the way you think about it, though, right? You would drop the 3 in front of it. So the 3 would go in there with the s. The s is a constant, so it kind of sticks with the 3 and the t, and then you drop that negative 3 down by 1. It becomes a negative 4. So you could write this as s squared minus 3s over t to the negative 4. I kind of think I might have seen it written as s minus 3 over t to the fourth, or even as s, something like that. Lots of different possibilities. All right, so here we are on the back now, and on the back, these are the more context-based questions. So hopefully you saw, like, on one side, we had questions that were more based on like computation, like get me a partial derivative, plug in some numbers. These were based on context and applying them. So there was one context-based question from 12.1 and one from 12.2. Okay, 3, that is, came from 12.1. And so this has to do with revenue functions. So Country Workshop manufactures both finished and unfinished furniture for a home. The estimated quantities demanded each week of its roll-top desks in the finished and unfinished versions are X and Y units when the corresponding unit prices are as follows. Okay, so the idea here is that you have a company. Now, this company sells a couple different products, but the products, in a sense, compete with each other in that if I'm an individual who buys a finished roll-top desk, I now no longer need an unfinished one. So as I purchase one, the demand for the other goes down, right? So they compete with each other. And this function, in a sense, kind of models that. All right, so what we need to do here is we need to find the total revenue function. So it used to be, when you had a single variable, that you would take the price of it and you'd multiply by the number that you sold. Here it's a similar idea, except now there's two variables that you're working with. So you know that you sold X units of P and you sold Y units of Q. So you're just going to do PX plus QY. That's how this one is different. So you're going to do RXY equals PX plus QY, which equals 200 minus 1/5 X minus 1/10 Y times X. Boy, I kind of wrote a little bit big there, so I move that over here. Plus 160 minus 1/10 X minus 1/5 Y times Y. right? Just substitute that this is what P is equal to, this is what Q is equal to. And now by distributing, I get 200x minus 1/5 x squared minus 1/10 xy plus 160y minus 1/10 xy minus 1/5 y squared. Now when I combine like terms, the 1/10 will subtract and it'll become negative 2/10, which is negative 1/5. So just be careful there. So you get negative 1/5 x squared minus 1/5 y squared minus 1/5 xy plus 200x plus 160y. Okay? And that's just moving stuff around and combining like terms that you can. But the big like terms you can combine are the negative 1/10 xy and negative 1/10 xy. And that makes negative 2/10 or negative 1/5, right? Dividing top and bottom by 2. Okay, that's your revenue function. Okay, second problem has to do with partial derivatives. So the productivity of a South American country is given by this function. And the productivity is determined by labor and capital. And X represents units of labor and Y represents units of capital. And so we need to determine the marginal productivity of labor and the marginal productivity of capital when the amounts expended on labor are 256 and 16 units respectively. So the first thing that should immediately send off alarm bells for you at this point is when you see the word marginal. When you see the word marginal, you need to think of derivative. Okay, and if I'm spelling that wrong, whatever, I'm willing to take that risk. You have to think differentiate. So, what you need to do when you see first of all, I don't want to get ahead of myself. X is tied to labor. Y is tied to capital. So when I ask for marginal productivity of labor, I'm asking for the partial derivative of F with respect to X, because X is labor. And to do that, remember we treat 20 and Y like they're constants, and we just differentiate X. So I'll have my 20. Technically, I'll put in I'll do this: 20y to the 1/4 times, and then we'll do the derivative of x to the 3/4. So that's 3/4 times x. We subtract the 1/4, we get negative 1/4. And then the 3/4 and the 20, those can multiply and become 15. The x to the negative 1/4 will go first, and then the y to the 1/4. When you think about marginal productivity of capital, that's when you differentiate with respect to y, because y represents capital. So now I'm going to treat x to the 3/4 and 20 as if those are constants, and I'm going to differentiate y to the 1/4 using the power rule. So 1/4 times y to the negative 3/4. The 20 and the 1/4 will multiply to get 5. And then I'll have x to the 3/4, y to the negative 3/4. All right, and so now what we need to do is we need to examine what is the marginal productivity of labor and capital at the point in time when we're spending 256 units on labor and 15 units on capital. So what they're saying is they want the partial with respect to x when x is 256 and y is 16. So that would be 15 256 to the negative 1/4. Okay. And so that is equal to, well, 16 to the 1/4 is 2. Because 2 times 2 times 2 times 2 is 16. Here, this would be, I know that 4 times 4 times 4 times 4 is 256. And since this is negative 1/4, I'm going to put the 4 down on the bottom. So I'll have 15 times 2, which is 30 over 4. So it's 7.5. Then we examine the same thing, but with y. So essentially what this says is that at the point in time at which I'm spending 256 units on labor and 16 units on capital, the amount that the productivity is changing with respect to the labor, right? The amount of additional productivity from labor is 7.5. So if you're going to spend another unit on labor, this is what you'd be getting out. If you spend more, this is what's happening with labor. Now, let's see what happens as I plug in here. So I've got 5. I've got spare 3/4 there. Make sure that's clear. So I've got 5. Now I've got 256 to the 3/4. And then I've got 16 to the negative 3/4. Okay? It's going to come down here. So 256 to the 1/4 is 4, because 4 times 4 times 4 times 4 equals 256. And then this is essentially 4 cubed. So that would be 64. Because, again, the quarter makes it, the 56 to the 1/4, that makes it the 4. And then this says to take that and cube it. Okay, here, if you remember, we did the 16 to the 1/4, that was 2. So now you do 2 cubed, that's 8. And since it's negative, the 8 goes down here. And so this 8 and the 64 cancel, giving you 40. So what does this mean? Remember, the marginal means how much additional are you getting out? What is the marginal productivity of capital? How much, if you're investing, the amount of productivity you invest as you add an additional unit of labor, the amount of additional productivity you get as you add a unit of capital, right? So if I go ahead and I dump in another unit of labor at this point, I'm getting 7.5 units of productivity out of that. If I dump in another unit of capital at this point, I'm going to get 40 units of productivity out. So what I'd be thinking about if I'm at this point is, where would I invest my money? And the marginal productivity of labor and the marginal productivity of capital, by telling me how things are going to change based on where I make the investment, kind of gives me some insight there. So I hope you were able to find this video to be helpful, and you were able to either get these right or understand what you need to do to improve. Please keep the questions coming as we move towards the final exam. As always, I'm here to help. Feel free to send me emails or questions or whatever. And I'll see you next time.